So now we're going to get into Newton's second law of motion. We've dealt with the first law of motion, and it's an important one. We need to understand it. It's if an object is in motion, it's going to stay in motion, or if an object is at rest, it's going to stay at rest, unless it's acted on by an outside force. And that unless is really important. It's really key to this second law of motion. So keep a couple of things in mind. If Batman is to throw a batarang at a bad guy, then this batarang is going to go forever unless a force is acted on it. That force might be the bad guy's head or the light bulb that he hits. You got to be nice. But either way, this thing's going to go forever until something else acts on it. So that's the law of inertia. An object will keep doing whatever it wants to be doing. Now, that's going to bring us into the second law of motion. Isaac Newton, he started making some observations, specifically about force and about mass and about acceleration. He was wondering, well, what happens about the unless? If an object does have an outside force acting on it, then what happens? And so he started to make some observations. Let's tie in this first one. The first one, he said, or he noticed that the amount of force that you apply to an object is going to be directly proportional to the amount of acceleration of that object. So if I apply a force with this hammer to this nail, then this nail should go down into the board. It should accelerate downwards. So I apply this small force to this nail. I should stand up so I don't smash my fingers. And it accelerates downward, just a little bit. But what happens if I change the force? What if I increase the force a little bit? Will the same thing happen? Or will it accelerate a little bit more? And so we do the same thing. And I'm applying a little bit bigger of a force. And you can tell that they're not lined up, that the one right here is a little bit lower. This one accelerated farther or faster than this one. But what if I increase the force again with one more nail and one more hammer? So now this guy, mighty Thor, and we do the same thing. I'm going to break my fingers on this thing. And we can tell that the acceleration is bigger. So little acceleration, medium acceleration, and large acceleration, because we have a little force, a bigger force, medium force, and a large force. Baby bear, mama bear, daddy bear. So he found out that force and acceleration are directly connected. If you double the force, you're going to double the acceleration. If you triple the force, you'll triple the acceleration, and on and on and on. The second observation he made was with mass. And he found out that mass and acceleration are inversely related. What that means is if I want to lift this hammer up, and I apply a certain amount of force, and then I want to accelerate it by throwing this hammer, it's going to go farther than if I was to throw this hammer, or if I was to throw this hammer. The amount of mass that I have in an object is inversely related to the amount of acceleration. So if I double the mass, the acceleration when I throw this is going to be half. If I triple the mass, then the acceleration is going to be a third. And he took those two ideas, the idea that force and acceleration are directly related, and the idea that mass and acceleration are inversely related, and he combined those together to give us Isaac Newton's second law of motion, which is force equals mass times acceleration. That's it. That's the law. He wrote it as acceleration equals force divided by mass, but it's the same equation, just rearranged. We could also write it as mass equals force divided by acceleration. What this tells us is that if you apply a force to an object, it's going to accelerate. How much? It depends on how much force you use and what the mass is. So the math really isn't too bad. It's pretty easy. You just have to make sure you know what your numbers are. Now keep in mind for units, we measure forces in newtons. So all the time that you write down a force, you need to have a capital N there for newtons. We measure mass in kilograms. So every time you write down a mass, put a little kg next to it, lowercase. And we measure acceleration in meters per second squared, which means meters per second, or meters per second every second.